We physicists have stood by without complaining for an impressive period of time, beginning around 1916. For this second, this is a close-up of a dark opening, quite possibly one of the most captivating and puzzling peculiarities known to mankind. Dark openings are gigantic in terms of gravity, yet, in many ways, they are practically elusive to us. A dark opening, weighing perhaps 2 to 4 million times the mass of the Sun, has remained a subject of interest. Over the past 20 to 30 years, we have gone from knowing almost nothing about dark openings to gradually uncovering more. Now, things have taken an even more extraordinary turn. As of late, Kaku reported that we have finally caught a glimpse of what lies inside a dark opening. This new information sheds light on nuances the scientific world may have initially overlooked. Join us as we dive deeper into dark openings and uncover what is inside them. Space is vast and terrifying. But what are dark openings? Before we delve into the nuances of Kaku's discoveries, we need to cover the basics. While most of us have a general idea of what dark openings are, gaps remain in our understanding. In 1916, Albert Einstein published his theory of general relativity, which predicted the existence of dark openings. At the time, dark openings were purely theoretical. It took another 50 years for established scientists to find evidence proving their existence. This breakthrough occurred during the 1960s when researchers studying the star Cygnus X-1 observed a strikingly bright blue star emitting X-rays. This star wasn't a dead object but was orbiting a massive dark entity. Further examination revealed that the X-rays were not simply floating randomly, they were being pulled into the dark entity. This mysterious object was named a dark opening, or black hole. This discovery was monumental because it proved that dark openings were not just the product of Einstein's vivid imagination, they were real. While this was exciting, it also meant there was a perplexing phenomenon in space that we desperately needed to learn more about. Scientists worldwide began studying Cygnus X-1, located in the constellation Cygnus, roughly 6,000 light-years from Earth. This dark opening was no small discovery. It is more than 10 times brighter than the Sun and is, unsurprisingly, incredibly dense, giving it a powerful gravitational pull. The concept of a dark opening is both fascinating and frightening. It is a region in space where gravity is so strong that nothing, not even light, can escape. Anything that ventures too close to a dark opening is pulled in and lost forever. The discovery of Cygnus X-1 marked the beginning of an era of dark opening research. Since then, scientists have sought other dark openings and discovered that there may be as many as 100 million dark openings in the Milky Way alone. However, due to their extreme difficulty to detect, the exact number remains uncertain. Despite this, we now know there are likely millions of dark openings in the Milky Way, making studying them all the more crucial. What makes dark openings so unique? The key characteristic of dark openings is their gravity. Their gravitational pull is so immense that anything entering them is compressed to an extreme degree, forming what is known as a singularity. In simpler terms, dark openings are like massive vacuum cleaners, pulling in everything around them. One of the most terrifying aspects of studying dark openings is that if someone were to fall into one, they would eventually reach a point where they are stretched into a single line. This process, called spaghettification, happens gradually, and the individual would die well before the actual breakdown of spacetime occurs. Fortunately, the closest dark opening to Earth is about 500 light-years away, so there's no immediate danger. In 2021, researchers released the first clear photograph of a dark opening, the M87 dark opening. This dark opening was captured over several nights, and with each image, scientists gathered more evidence. They had to combine individual photos to fill in gaps, which allowed them to confirm that dark openings have 3 distinct layers. Contrary to popular belief, a dark opening isn't a single void of nothingness. To even reach the void of a dark opening, one must first pass through its 2 outer layers. The first layer is known as the event horizon. This is the point of no return. Once you cross it, there's no escaping the dark opening's gravitational pull. The second layer is the photon sphere, where light orbits the dark opening. Any light entering this region is trapped and cannot escape due to the immense gravitational force. Finally, we come to the third layer, the singularity. This is the core of the dark opening, where everything that enters is compressed into an infinitely small point. At the singularity, the laws of physics as we know them completely break down, and we cannot predict what happens next. Each dark opening is unique. While they may follow the same basic three-layer structure, their behavior and characteristics can vary greatly. How do scientists study dark openings? Studying dark openings presents significant challenges. Since anything entering the event horizon is pulled into the singularity, it is impossible to send a probe to investigate them directly. Therefore, scientists must study dark openings indirectly by observing the radiation they emit and the gas and dust surrounding them. Despite these challenges, researchers have developed many theories about how dark openings form. One of the most compelling is that dark openings are formed from the collapse of massive stars. When a star exhausts its fuel, it can no longer produce enough energy to counteract gravity. The star then begins to collapse in on itself, becoming denser and denser. If the star is massive enough, this process continues until it forms a singularity. In an effort to better understand dark openings, NASA turned its attention to the center of the M87 galaxy. Astronomers observed a massive whirlpool of incredibly hot hydrogen gas spinning at a staggering speed of 1.2 million miles per hour. This rotation should have caused the gas disk to fly apart, but it didn't. Scientists concluded that a massive object at the galaxy's center was holding everything together, a mass equivalent to 2 to 3 billion suns. The discovery of this colossal dark opening in M87 confirmed the existence of supermassive dark openings at the centers of galaxies. But even this observation only scratches the surface. Alternative theories and mysteries. While the theory that dark openings form from collapsing stars is widely accepted, there are alternative theories regarding their origin and nature. Some scientists suggest that dark openings may have formed shortly after the Big Bang during the early stages of the universe. These hypothetical dark openings, known as primordial dark openings, could vary in size and mass, from tiny to extraordinarily large. Another intriguing theory posits that dark openings could act as gateways to other universes. This idea stems from the concept of a wormhole, a hypothetical tunnel in spacetime that connects two separate points. While there is no direct evidence for wormholes, they remain a popular topic in theoretical physics and science fiction. Furthermore, there is ongoing debate about what happens inside the singularity of a dark opening. Since the laws of physics as we know them break down at this point, some scientists believe it could hold the key to a unified theory of quantum gravity, a framework that bridges the gap between general relativity and quantum mechanics. What's next for dark opening research? The first photograph of the M87 dark opening was a groundbreaking achievement, but it was only the beginning. Scientists are now working to capture clearer and more detailed images of dark openings using advanced telescopes, such as the Event Horizon Telescope, EHT. In addition to imaging, researchers are studying gravitational waves, ripples in spacetime caused by the collision of massive objects like dark openings. The detection of gravitational waves by LIGO, Laser Interferometer Gravitational Wave Observatory, has opened up a new way of studying dark openings, providing insights into their formation and behavior. One of the most exciting developments in dark opening research is the investigation of their role in galaxy formation and evolution. Supermassive dark openings, like the one in M87, are believed to influence the growth and structure of their host galaxies. Understanding this relationship could reveal new information about the history of the universe. A glimpse into the unknown. Despite decades of research, dark openings remain one of the greatest mysteries of the universe. They challenge our understanding of physics, push the boundaries of technology, and inspire countless questions about the nature of reality. What lies beyond the singularity? Are dark openings connected to other universes? Could they hold the answers to the origins of the universe itself? For now, these questions remain unanswered, but with each new discovery, we draw one step closer to unlocking the secrets of these enigmatic cosmic phenomena. The journey to understanding dark openings is far from over, and the next breakthrough could redefine our understanding of the universe as we know it. In 1963, New Zealand mathematician Roy Kerr used Einstein's equations of gravity to provide the best description of a rotating dark opening. He showed that a rotating dark opening would not collapse into a single point, as previously thought, but rather would form a ring of fire or a thin disk. This disk would spin so rapidly that centrifugal forces would prevent it from collapsing. This rotating disk of matter is known as the ergosphere, the region surrounding the dark opening where the laws of physics begin to break down. However, the most fascinating feature of Kerr's model was its prediction of an Einstein-Rosen bridge, also known as a wormhole. This is a hypothetical tunnel through spacetime that connects two separate regions of the universe, or even two parallel universes. The idea is that if someone were to fall into a dark opening in just the right way, they could theoretically pass through the wormhole and emerge in another part of the universe, or even a different universe altogether. Of course, this remains purely theoretical. Wormholes are unstable, and any disturbance could cause them to collapse. But the concept has sparked the imagination of scientists and science fiction enthusiasts alike, keeping the possibility of interdimensional travel alive in the realm of speculation. Future prospects in dark opening research. As our technology advances, so does our ability to study dark openings. Scientists are working on building more sensitive instruments, such as next-generation telescopes and interferometers, to study the subtle effects of dark openings on their surroundings. Gravitational wave observatories, like LIGO and Virgo, are also being upgraded to detect fainter and more distant events, providing even more insights into the behavior of dark openings. Additionally, researchers are exploring the use of artificial intelligence and machine learning to analyze the vast amounts of data collected from telescopes and other instruments. These technologies could help identify patterns and phenomena that were previously overlooked. Finally, space agencies like NASA and the European Space Agency are planning ambitious missions to study dark openings more closely. These missions include sending probes to observe the regions around dark openings and potentially testing some of the more exotic theories about their nature.